Okay, temperature final is 31, so my change in temperature for this one is 38 degrees Celsius. I can just look at that. The other cup, this temperature was higher, 69 degrees, so the heat went from the one cup to the other even when you added them. So this temperature was initially 22 degrees. Oh, this I know is 55 grams. It's the second cup that I don't know. So the mass of this equals question mark. And the delta T, I went down or up from 22 up to 31. So that would be 9 degrees. This temperature fell, so this one's negative. Okay. Here's what I can do. I can say Q equals Cp times M times delta T. I can use that for both cups. I can set the Q's each other, and then I can say, well, Cp times the mass times the change in T is equal to Cp times the mass times the delta T of the other cup. Cancel out the Cp, so I know that 55 grams times the delta T was 38 is equal to the other mass times the delta T is 9. This would be a negative of a negative, so the sign just becomes a positive. So the mass of this is 55 times 38, and then I'll divide by 9 to get the mass. So 55 times 38 divided by 9, looking at 232. So this one was 232 grams. A. Okay, again, the secret was looking at Q1 and Q2. This is mass 1, this would be mass 2. Delta T1, this would be delta T2. And what I did is I set the two Q's equal to each other. Okay. This is kind of classic calorimetry when you set one equal to the other. This one is a real easy one. I have a Q, 73.51 joules. Okay, I have a mass, 25.6 grams. I have a temperature, initial. This is 25.3. I don't like to get hung up on the negatives and positives of this, so it tells you heat's added. So I know that the temperature is going up. Now, to simplify things, I'm going to solve for delta T. I'm not going to get into the TF minus TI, and so I'm just going to make it real simple. Q equals Cp times M times delta T. I'm trying to solve for delta T, so algebraically, delta T equals Q over Cp times M. Let's make life simple. 73.51 joules. Cp, 4.184 joules per gram degrees Celsius. Joules just canceled out. And temperature change is what I'm after. And this is the mass of the water, which is 25.6 grams. Grams cancels. As units, I got 1 divided by 1 over degrees Celsius. So if you divide by a fraction, you invert and multiply. So your units come out to be degrees Celsius. 73.5 divided by 4.184. It's always good to think about units and not ignore units. I got 0.686 degrees Celsius. I think 3 sig figs is fine. Now here's what I get into. I want the temperature final. Well, the temperature final, since this is exothermic, is I'm going to add the 24.3 to that, and that's just going to become 0.7, so the answer is going to be 26.0 degrees Celsius. A. Okay, after going through that one, we go through really easy ones. Q equals Cp times M times delta T. there's my change in temperature. My delta T is 5 degrees Celsius. Okay, my joules, well, I'm trying to find grams, so I'm going to say mass equals, solve for M, Q divided by Cp times delta T. So I got 324 joules, 4.184 joules per gram per degree Celsius. Joules just canceled. And then divided by also the 5 degrees Celsius cancels. So I get 324 divided by 4.184 divided by 5, and I'm looking at 15.5. Or I could just say I think it would be 16 because the 5 is a 5.0, so really 2 sig figs. But 15.6. I think it should be 16. This one will drive everyone crazy. Everyone will ask me for this. Very simple. Okay, the specific heat of bromine is 0.226 joules per gram of bromine per degree Celsius. The molar heat capacity, this is specific heat is in grams. Molar heat capacity is in joules per moles of bromine per degree Celsius. Well, all you got to do is convert a gram of bromine to a mole. And remember that bromine is diatomic. So grams of bromine on top. Bromine 79.9 times 2. 159.8 to 1 mole of bromine. That's the problem. I just converted grams to moles, dimensional analysis. So 0.226 times 159.8, and I get 36.1. B. All right, I'm going to finish the rest of this on the next clip.